So what Solidity does is if you use data types and they actually fit together within the 256 bits, is it'll actually put them in the same storage slot. And this will save you a lot of gas because outside of the operation itself of reading and writing to storage, like reading from two different slots costs more than reading twice from the same slot, because there's this concept of warm and cold in the EVM. So there's warm and cold storage slots and addresses. The first time in a transaction where you read a slot, it'll have like a one-time fixed cost, because if you imagine what the blockchain client is basically doing in the background is that it has to read the disk, and then afterwards it's in RAM, right? So you can just like quickly access it, but that first overhead, it basically has to account for that. So that alone is a lot of the savings. And then also like modifying the same slot multiple times is cheaper than modifying two separate slots. Packing basically allows you to leverage those savings without really having to worry about it yourself, just by using smaller data types in your structs and variable definitions.
GM, Philogy, how's it going?
GM, DeGatchi, great to be here. Yeah, cool that you're starting a podcast.
Yeah, this is a first time, and we're going to see how this goes. But let's start off with who you are and what you do.
My name is Philip. I'm known online as Philogy, and I'm a smart contract developer, auditor, and just like general optimizer, and currently working as a co-founder on DeReg, a security project that focuses on circuit breakers.
Circuit breakers, interesting. So past auditor, now optimizer developer. So I want to learn about a bit of your starting of your career. So let's start with that. Let's dive into the start of your career and see how it progresses.
Yeah, so I started coding very early, actually. Like the first time I coded was like at the age of 10, but then I didn't really know how to code. I wasn't very good at it. I almost gave up with it, but I continued doing it on the side, like very slightly. But I stupidly, as a small kid, tried to start with like really hard languages like C++ and C#. But eventually, at the age of like 14, a friend showed me Python, and that's like where everything kicked off. And I really got into just like programming and doing like just different bits and bobs of my computer, and that was actually really cool. And at the age of 15, I got like my first unpaid internship at like a tech startup, which was like really cool because
15.
I was like writing. I mean, it was part of like high school. We had to get like an internship. It's like a company, and like most people, they just like went to kindergartens or like a hospital or somewhere to just like do their 1 week. But my brother was working at a tech startup at the time, and I asked him like, hey, could I do something cool for my internship? Do you think I could maybe get a spot at the startup you're working at? And it's like, okay, I have to ask my bosses. And then they said, okay, well, they're a startup and they don't really have time to like babysit a kid, but if you can like pass this like small coding test, then they know you can actually like maybe even help them a little bit during the 1 week. So they gave me like a small coding test that I did on my phone in the school like lunch break, and then I actually passed, so that was cool. And then I got the 1 week there, and then they actually I actually asked them if I could like work for them in the summer. And then when I was 16 in the summer holidays, I went back to work for them like full time for like 1.5 months.
Oh, nice.
Which was also really cool. So I was just like doing front end development and debugging. Actually, it was really annoying because I was the only person who had like a Windows laptop. Everybody's working on Linux. What they had me do all the time was like debug the Internet Explorer bugs in their front end.
Oh, interesting.
So that was a really annoying time to start. But that was like,
auditor at the start.
Yeah, basically, that's like how I got my intro to tech, and then it just went on from there. Like I continued to work at the startups where my brother was working at, and eventually he founded his own, and I worked for him there for a while before like quitting that to just be a freelance like smart contract developer. When I was like at the age of like 17, like next to high school, I started like freelancing for just like random different companies, and like this DAO that I worked for a while called OneHive. I worked for them for like I think almost a year. Just like next to high school, just like working different projects, which was actually like really fun, and also earned me like a bit of pocket money, which was cool as a high school student. And then eventually I went to university, started my CS degree, but then I very quickly realized that was not for me. And then when QuantStamp, the security company, gave me an out via a job offer, I was like, yeah, hell yeah, I'm going to take this, because instead of like learning about like CS fundamentals, I get to learn about crypto and earn a pretty decent salary. Yeah, especially for a 19-year-old kid straight out of uni. So I took that, and then
how did you like get that offer from QuantStamp if you just came out of uni, didn't have any experience? Was it just kind of like you had a connection there, or did you do like sort of auditing on the side and gave like reports and made sort of a resume?
So it was my first like real security job. But before, as I was freelancing, I already like taught myself about security, just like as an effort to become a better dev, because I realized like, yeah, I'm a developer, I'm writing these things for the DAO, but like what's like the next step to getting better? And then I realized like, hey, like a big part of DeFi projects is that they get hacked. And as a good developer, like maybe I should write code that doesn't get hacked. So I started like learning about security just from the perspective of a dev. So I did like the Ethernet challenges and like the puzzles and just like learning about security.
Right.
And it was like very fun to just like try and take apart code and like see how you can write code in a more intentional way. And then how I got the job actually was that at university they had like this hackathon, and then there were like all these like big old boring Web2 companies like I forgot how they're called, but you know they like Salesforce, like these really big companies, conglomerates that do these different types of softwares. But like QuantStamp was like the only crypto company there. I was so excited because I was really into crypto at that time. I was like, okay, only crypto company there. Let me do their hackathon, which was like a security challenge. So basically, you had like two phases. You had to first you had like your team. You know, like, as part of a hackathon, you always have to make a team. And it was this really cool challenge because the first step, you had to develop a smart contract that fits like a spec. And then at the second step, you had to deploy your smart contract to a testnet, and then you had to try to hack the smart contracts of the others. So obviously we were at a real advantage because I was basically the only person in the entire like hackathon participating in the challenge who had like any major smart contract experience, let alone like security experience.
Oh, right.
So we kind of crushed it because of that. And then after that, the guys at QuantStam were like, hey, that was actually a really cool performance on your part. Do you want to like apply and like see if you get a job? And I was like, hey, I'm a first semester CS student. I don't think I have a chance here. And I said like, yeah, just try, just apply anyway. Like, let's see. And
right. So
I applied. I went.
Sorry.
Yeah, sorry.
It all started at like a hackathon basically, and you just performed.
Yeah, exactly,
well,
exactly.
And then they just were like, yo, come apply. You've got a chance. Don't worry about it.
Exactly. That's how it was.
Word. And so from that, you applied, and then you obviously got in, right? I guess what was kind of like that onboarding process of, okay, going from, you know, a smart contract dev to I guess like a junior auditor at the time. How was that?
Actually, funny thing, they hired me directly as a senior auditor.
Oh,
I was the youngest senior auditor there. Yeah, but the way that worked, so yeah, I had the coding interviews. They had like a 3-step interview process. The first was like Solidity security tests. Then they had like a general like Web2 security test.
Okay.
And then they had like a third like a general coding test. But apparently I did so well in like the first two that they said like, yeah, we'll just skip the third and I'll just go straight to like salary negotiation stuff.
Got you.
So we went to that and I just chatted with them and then I accepted the offer. Initially it was part-time because I had like this small side project I was working on that I wanted to continue building like next to my job. So that's why initially I went part-time for them.
Got you.
And then the onboarding process was pretty cool. So I think almost immediately. So the first 1-2 weeks was just like re-auditing an old client because they had like the standard basically repo that they had new auditors basically just like look at and find issues on to basically get them familiar with like the process, with like how you write notes.
Okay, so a bit of shadowing auditors stuff.
Exactly.
Yeah.
And then I got assigned to my first audit. Which was actually like really terrible, just from the perspective of what I had to audit. Yeah, because it was like this really messy, like really bad code base, which was like a fork of Yearn, and they had like 20 different strategies and adapters that were all like really badly tested and written.
Okay.
They had like basic no coding practices and just like finding issue after issue, just like really basic things.
Yeah.
So it was like really
you're basically
really
thrown into the deep end.
Yeah, basically, yeah. But it was cool.
And like kind of like the worst of the worst, right? Like, I guess how do you even like deal with that kind of like raw project? And like, how did you approach going against that? Because usually what you would hope is a project would have great tests, great documentation, and that wasn't provided, right? So how did you go about doing that?
I just went through it step by step. So I looked at the project as a whole. I spoke to the team and we understood like what they wanted their project to do, right? Was it like a yield aggregator? They had different strategies. And then just going through the files one by one, seeing based on what they were named, like what they were meant to do. So, okay, this is like a strategy for like compound token, like compound USDC or whatever it was. And this strategy, or this like, because basically the way your vaults work is you have like the vault and you have like all the strategies that like plug in essentially.
Yeah.
I like those strategy contracts, like this modular architecture. And so I was like just like looking at the individual strategies and like, okay, here, like there's no slippage checks, like here, okay, some decimal, whatever. And just like going through it. And that was basically the process, just like going through it and doing a manual review. And also when you have a code base like that, there's like, it's basically just like uncovering the amount of like huge mountain of issues you're going to find and giving that as to the client. And then like, hopefully they'll realize, okay, our code is like really bad, and they go back to the drawing board or like do more heavy testing on their end.
Yeah.
But I feel like that's kind of common, or not that common, but it did happen a lot that you had like clients that just like didn't have the best code bases, or at least not the way you wish they were as an auditor. You know, like, okay, ideally they have like these great tests.
Yeah.
They have a specification, they have docs, they have NetSpec comments everywhere. But yeah, it's rarely like that.
All your expectations were just not there, basically.
Yeah, exactly. Because at the time I didn't know. Because at the time I didn't know how much like firms charge for audits to their clients. But I imagine like, hey, if you're gonna have like these, if you're gonna hire these external professionals to look at your code, like I'd imagine you would first invest like a tiny bit of effort into just like at least applying like a code formatter, maybe adding a few comments, maybe docs, hopefully.
Hopefully,
but, yeah, that was that was like really present, which was very surprising. Like, okay,
yeah, it's quite like interesting that projects don't do that, because it definitely helps with the process of building the projects in the first place. But then you have these outside contributors basically criticizing code and trying to understand it, like a whole project from scratch, basically in a couple, days or weeks, and they have nothing to reference, So it's kind of crazy that it's not common. But then, like, what happened after QuantStep? Like, you're not working there now. So what kind of happened after?
Yeah, so what happened after is I was working there, and then eventually I realized, like, I don't want to be an auditor, not only because I wasn't really having that much fun. I realized that also internally, when we were given, like, a bit of, like, side time to do side projects, I was, like, just really interested into how do you develop smart contracts better.
Like your focus.
Yeah, on the one hand, you see, like,
path.
Yeah, exactly. And also just realizing I just didn't enjoy auditing that much. It was just like looking at these code bases with like kind of this similar vulnerabilities, and it's just like projects basically forking each other, and it wasn't really that interesting to me, I realized. And then eventually I also realized, like, as a person, I wanted to have more impact, or like more scale. And like whenever you're working like as an auditor or like as a software developer, it feels like you're very limited in terms of like the scope of your impact. Okay. So I just wanted to go back to working my own projects. And so I left to start a project with my brother.
Oh, with your brother. So that's your project DeReg, right?
Exactly, yeah.
And that focuses on security standards and infrastructure. So I guess what are you building now with DeReg, and what's the kind of in the pipeline? Yeah,
so what we're building right now is... So we're building on two paths, because me and my brother, we have like different expertise and focuses, but they will like overlap and combine down the road. But basically, we're building, on the one hand, we're building circuit breakers. So this is like on the smart contract development side. This is meant to be like a standard and library you can integrate into your code to easily add like a backstop essentially in your code. So even if your core logic is faulty or has a mistake, like the losses from an exploit will be capped like to whatever rate limit you set.
Yeah.
And then on the other side, we're like building infrastructure to like monitor, transactions and DeFi protocols, so that'll plug into the circuit breaker, in the sense that once you have the circuit breaker, you want to know when rate limits are hit or when suspicious activity is engaged, so that you can like intervene and like pause the protocol when needed.
Okay, so basically it's like a pause when there's a certain amount of like activity happening. Mm-hmm. Got you. And what kind of got you into building this stuff?
Yeah, so I actually like had the idea for this like while I was working as an auditor, and I was just thinking, like, is there like a low technical complexity way that is like general purpose for DeFi projects for them to like secure their code base against like logic failures like in the main code? And then I thought of like this really simple architecture where, what if you have your DeFi application and then you just put it in like a standardized container that just like delays all the outflows of assets, so that you can track them off chain and then stop them if they're malicious. Because this can be applied to basically any DeFi protocol where its main targets are its assets. You can just like put it in a wrapper that says, hey, anytime an asset goes out, it'll leave, but only after delay. So we can just like keep track of it and see if anything goes wrong, we can block it.
Right. So if someone did
regardless of
like
what-
basically an exploit, you would see like a massive amount of tokens like being in like a backlog basically. You'd be able to identify that and just stop it, correct?
Exactly. That's the goal. So it doesn't say like, hey, we'll prevent your code from ever having bugs. We'll say, okay, we'll assume your code has bugs, but when it does, like, how do we create a system that can like catch that in a general way and be applied to basically any project?
Right. And I guess like one of the cons of that, like that's a terrific pro, but I guess one of the cons is like, what if someone desperately needed that at like an instant? Is that something like configurable or something for a protocol? Because it's kind of like a double-edged sword in a way.
Yeah, so that's one issue. You don't get like direct atomicity. So there's basically two ways you can kind of mitigate this, but you can't like fully solve it. Is on the one hand, you can use a rate limiter. So instead of like delaying everything by default, you can have your project have like an on-chain rate limiter that basically tracks the in and outgoing volume. And then it says, okay, like funds can flow freely, like instantly in one transaction, as long as the general volume is within a certain bound. And basically what that does is like, let's say you can at most like withdraw 10% of the TVL within 24 hours. So in most cases, like funds will flow freely. And if there's ever an exploit, then you'll cap your losses at the max drawdown, which you can set as a parameter. So if it's like 10%, then you'll lose only up to 10% of your TVL within the 24 hours. And then if you have like a monitoring system, you can like react fast enough and like shut it down. So that's the first way.
Got you.
And the second way, what we're working on, what we haven't quite started working on, but what we think will be like the big kind of the big thing is real-time underwriting. So basically what you can do is you can have like a risk taker, a third party that basically pays out the value of your transaction in advance and basically gets paid out once the actual outflow gets settled. And what this does is that for users of the protocol, it looks like they're having like an atomic interaction in the sense that in one transaction, they're submitting it to the chain, it gets mined, and then gets included in the block, and then they get their assets out of the protocol. But what happened in the back end is that actually they got paid out by a third party that is actually getting their withdrawal, and then they have to pay like a tiny spread or fee on it.
Interesting. Right. And like, again, what made you think of this to build?
What made me think of the underwriting part? I don't know, it's just thinking from first principles, like how do you, so you have this fundamental reality that transactions are like slowed down now. So what are ways where you can basically still have the security properties of, you can
It's like a Lego,
essentially reverse or like block the backlog, but you can still have end users or have it seem like for end users, like their transactions are instant. And then basically it's like the only way you can do that is if somebody else pays out the funds. But that creates a cool ecosystem where you can have like multiple real-time underwriters competing and being experts in underwriting different transactions and basically like pushing down the spreads for users so that fees are like extremely low. And also just like calculating like what rate of return like these underwriters might expect. Like the fee is probably going to be like super low, like in the low basis point range.
Yeah, got you. And some other projects you've made have also been in Huff. So basically the lowest level you can get, basically writing in bytecode, except a step higher, so mnemonics. And you've written the most optimized version of WETH, as far as I know. Can you run us through that? Like, how did you even get into that, and why did you think of doing that in the first place? Was that kind of like a...
Yeah, so...
Continue, sorry, my bad.
Yeah, all good. Yeah, so wrapped ether. So also from my auditing days, I saw a lot of times where people were using wrapped ether with like certain patterns, I would say. So like a very common pattern that is even present in Uniswap is like the deposit and transfer pattern. So you would one time call wrapped ether to deposit ETH, essentially wrapping it to wrapped ETH and then transferring it using an ERC20 transfer to an address. And other times where you transfer from and then unwrap it into ETH and then send the ETH somewhere, and like all these super common patterns. Yeah. So that's kind of like the first thing, like creating contracts that allow you to execute those within one call, because it's not only about essentially bundling all of these steps into one call to save on the call overhead, but it's also like under the hood, like what happens is that you have these ERC20 balances that are changing for the sender and recipient, and then changing the recipient again, and like all these gas costs add up. So just like having a contract that allows you to bundle these patterns into one call. But then like looking deeper into wrapped ether, I saw like how fundamental it was to the ecosystem in terms of like how much gas is spent yearly in Ethereum just like interacting with wrapped ether. I think from the numbers I've seen, it's like 5 to 7% of like all gas on Ethereum is spent within wrapped ether. So I thought, okay, it might be really worth it to like rewrite it from scratch at like the lowest level to save every single gas possible, because these functions are going to get called like millions of times. So if you can actually get people to use your new implementation, you can potentially save the ecosystem like millions of dollars yearly in gas fees.
5% or whatever they're using. Well, not 5%, but like a portion of that, And I mean, like,
exactly.
Wrapped ether is in almost every protocol, or it's integrated in some way. So I wonder why. Maybe you can make like a standard and it, people adopt it. But I guess the only downfall is like the tooling for Huff and testing it is honestly not the best from experience. Maybe someone looks into like tooling, but you see big protocols like Seaport, like OpenSea, they had tons of transactions going in. Like the biggest NFT platform in the world is just, millions of transactions. People are spending unnecessary gas because the Solidity compiler isn't as optimized as writing, a hyper efficient contract like this hyper optimized WETH contract. So it's definitely like a massive market, but I guess why don't people use it in production,
You mean my WETH implementation or Huff?
Just in general, like Huff.
Yeah, I mean, the issue with Huff is that it's, number one, like the amount of auditors you have like in the industry is already like kind of limited. And then if you look at auditors that are able to really give you like good guarantees when auditing Huff, is probably like even smaller. And then in general, like as you mentioned, like the tooling is not that great, and also there's so many footguns. Like there's a reason Solidity has all the overhead it does like on the lower level, is because it really maximizes safety, and it says like, rather than like risk having a bug in the compiler by like doing this small shortcut here, we'll just like have it in a verbose like safety first way. And then like ensures, like I think in the history of Solidity also, I think there's very few times, if ever, that you had like a really severe bug in the actual compiler itself. I think there's like only one or two you can recount like for the entire history, which is like quite impressive for a code base that is as complex as Solidity. So and then if you write Huff, like you get all the advantage of having direct access to like the bare metal of the EVM, but then you have like all these things that you can do wrong. Like now you don't need it anymore, but like an old trick used to be they use the return data size opcode, so you can push 0 to the stack with 2 gas instead of 3. But for example, like if you call another contract, it can change the return data size, and if you're still using it afterwards to push 0, it might actually push another value, and then it can have a bunch of cascading effects. Or if you have like your custom memory layout, then you can accidentally things can overwrite each other in memory, or custom storage layouts, you can have like collisions between different mappings and like all kinds of funky things.
Just basically like a massive, you're just introducing new attack vectors, and maybe you're not as experienced with it. It's very easy to basically forget about what's happening on the stack. Even if you write it out, it's quite difficult to kind of keep everything in your head, especially jumping from like implementing stuff and then, okay, I forgot this, I have to change the start of it, because you're basically managing the stack and what's going on in that. It's quite difficult. But you've also built like other projects like ERC721H, which is a Huff rewritten version of ERC721A. I guess that's kind of like the same thing, isn't it?
Yeah, that was like my first big Huff project. So I just wanted to really get into Huff and like use Huff. And then I saw that ERC721A was like the hyper optimized implementation of ERC721 that everybody was using at the time during the NFT hype, because you could batch mint like thousands of tokens for really cheap in comparison to other implementations. So I thought, that would be like a cool contender, because that's also what kind of like nerd sniped me into using Huff. It was a way to kind of like show off your skills as a dev and show that you can write like a more optimal contract than others. And then I saw everybody because by the way, like ERC721A by Vectorized is an extremely great contract, but I saw everybody putting like this contract, this implementation on the pedestal. It was like, oh, look at how much gas it's saving me on my newest NFT mint. And I was like, okay, I want to write this better and show people. And then I just started writing into it, and like weekend after weekend, just like bringing it forward, because it does take a really long time to rewrite things in Huff, especially when you're first getting into it.
Yeah, definitely.
But eventually I finished it off, and and you constantly get better as a dev. So even like looking back to it now, because I haven't looked at the code base in a while, like there's so many new tricks I've learned writing Huff even like looking at my old Huff code, it's not as optimal as it could be, or as I would write it today.
For sure.
But it was a really fun project to build.
So like that was your first big project to really get into Huff. I guess what are some, if you were to redo it, what would you do again to basically accelerate this learning? And what kind of like difficulties did you have first learning that you wish you knew prior?
I think in terms of like relearning, I don't know if I'd really do anything differently, to be honest. Like I think it's all about the practice, because there aren't that many resources about Huff in the wild. So it really is just like you're almost down to your own to basically like learn it and get better. I think another thing that I probably would have done earlier is like join communities with like top tier devs. So like just like join the Huff Discord or other Discords where people are really focused on these kind of things.
Yourself.
So like public Discords I can recommend for this are like the Huff Discord and the Solidity Discord. There people are like really focused on optimization and just making sure contract.
To be around people you definitely want to be like, right? And I think the Huff Discord is perfect for that. You're getting into like the bare bones of smart contract development, and it's a very niche skill. And I wonder if there's ever going to be like a Huff auditing market maybe in the future. If people start to adopt like low level kind of contract development, even though it's quite difficult to, build production ready contracts, possibly. I mean, I have no clue if people continue to use Ethereum as much as now versus like L2s where gas isn't really as important, then we'll see, but you've also built like a ERC 4337 wallet implementation. Again, another efficient contract. How did you get into that again?
It was another nerd snipe. So there's this friend I met at
they've just got a cop here on you.
Just different people. It was actually a funny story, because I met this I made this new friend at Zuzalo, like in Montenegro, and she was basically this dev like working on a 4337 wallet, and she was telling me like how 4337 wallets are like really expensive in production, and that they're like 10x more expensive than like an EOA wallet. And like at the time I had never written a 4337 wallet, but I was familiar with the standard, and I was like wondering like that cannot be, like, because in my head, like just running some really back of the napkin calculations, I was like, actually 437 should be like barely more expensive than an EUA, if not cheaper if you batch like transactions. And I thought, okay, this is interesting. Like why are they getting like 10x worse gas performance? So that was like kind of the nerd snipe of like, okay, can I do it better?
What exactly is 4337, just to let people know that don't know,
Oh yeah, definitely. That's a good point. So 4337 is an ERC, meaning it's a application level standard and not the Ethereum like blockchain consensus level standard. And basically it's a way to standardize how smart contract wallets can have customized authentication logic, but like have a standardized way to like validate and basically sponsor gas for these smart contract wallets. Because the issue today in Ethereum is that every top level transaction has to be initiated by an EOA, which is basically which stands for externally owned account.
MetaMask.
So this is an account that's exactly. So these are like accounts that are owned by a private key directly. So there's no smart contract code associated with them. It's just like the blockchain says, hey, can you give me a valid signature for this account? If yes, you can run the transaction. If no, you can't. Versus smart contracts, which can have like, any custom logic. And then basically what ERC 4337 does is it standardizes a way how you can like bundle transactions and then have somebody else, like another EOA, which was basically your bundler, that pays for the gas, that then actually runs the code of your smart contract wallet. And then your smart contract wallet obviously pays for its own fees, but you need like a standardized way to do that, because there's like a bunch of security issues that you can get if you try to implement that yourself. Like, you can DOS the different you can DOS bundlers, you can steal like wallets, there's like a bunch of different things that can go wrong. So the standard basically gives you like a secure framework of doing that. And then, basically I was nerd sniped into like, hey, this seems like way too much, like 10x. So I just like looked into it, started writing my own implementation. and I did get it down, but I did find out at the end that um, ERC 4337 wallets are definitely going to be more expensive than EOAs, but they don't have to be that much more expensive.
For sure. And like it's all done in Huff as well, isn't it?
No, it's not all done in Huff. So the main optimizations actually
Okay.
come from like high level design choices.
Oh,
So that's also what I tell people a lot, like especially people who are newer to smart contract development. Like most of your savings will come from like the high level design decisions you make,
right.
and just like using like the really expensive resources like storage efficiently, and then like Huff will get you like the last mile basically, right? Like
Yeah.
removing Solidity's overhead. But that's like really like you can get a lot of savings just from like the high level
So like what are some
design.
examples of some high level pitfalls that people are sort of implementing?
When it comes to wallets, or you mean like generally?
Just generally. Like Huff is
Oh,
obviously the
generally. Okay, okay.
extreme, hyper optimized, the best of the best. Obviously not a lot of people are doing that because it's so niche and unnecessary. A lot of people are doing Solidity, that's how they get into it, that's how it's easy to maintain as well. So if high level architecture is a difficult thing to be a master at, like what are people doing that they're getting wrong?
Okay, so there's a few things. I want to start by kind of like a meme slash rant on the diamond standard. So I would say like too many people jump to trying to use the diamond proxy standard for their contracts,
Okay.
which is really unnecessary and has like a bunch of other pitfalls besides like efficiency. So that's one I would call out here because when you write code using the diamond proxy standard, it can look very elegant, it can look cool, but the end result is often not so cool and unnecessarily like complex. But in general, it's just like the most expensive thing in the EVM is like permanent storage. It's like what gets stored between transactions, and basically just making sure you use that effectively is probably one of the larger things that people get wrong. So like there's really basic things like if you load a value from storage, like balance of a token or thing, and you need it for like a calculation, just like store that in a local variable and reuse that a bunch of times, or just like look through and calculate like the bounds on your logic, like how large will a variable ever possibly be, and then you might realize that hey, like this timestamp, it will never like need more than 32 bits, so I can store it in a UN32, and then this will allow you to basically pack things together.
Right.
So that's like
What's
where really
packing?
big savings come from. So packing is something the Solidity compiler does for you automatically. So there's different data types and like sizes they take up. So like a UN32 means it takes up 32 bits. It's like the maximum. It's like the range.
Yep.
And then you have UN256, which is kind of like the quote unquote default integer type, which is like up to 256 bits, which is also the EVM's like internal like word size. And that's also kind of if you look at storage, it's written and read from in these like 32 byte or 256 bit increments. So what Solidity does is if you use data types that are smaller than that and they actually fit together within the 256 bits, is it'll actually put them in the same storage slot. And this will save you a lot of gas because outside of the operation itself of reading and writing to storage, like reading from two different slots costs more than reading twice from the same slot, because there's this concept of warm and cold in the EVM. So there's warm and cold storage slots and addresses. So warm and cold storage slots basically means that the first time in a transaction where you read a slot, it'll have like a one-time fixed cost, because if you imagine what the blockchain client is basically doing in the background is that it has to read the disk, it has to put it into RAM, and then afterwards it's in RAM, right? So you can just like quickly access it, but that first overhead, it basically has to account for that. So that alone is a lot of the savings. And then also like modifying the same slot multiple times is cheaper than modifying two separate slots. So things like that. And then that's packing basically allows you to leverage those savings without really having to worry about it yourself, just by using smaller data types in your structs and variable definitions.
Yeah, like the main high level, I think, is definitely storage access. So, you know, loading in data from storage or even storing data into storage is quite expensive, and you want to kind of minimize that as much as possible. And I think another like big one is using memory properly, because when you declare memory from a storage slot, you're actually loading that storage slot into the memory first, and then you're going to use that memory after. So you want to make sure that if you're doing a for loop, you don't want to keep loading it into memory in each iteration because you're going to access it either way, right? So you want to just access the storage directly instead of spending the extra gas just to put it into memory, then use the memory again. You get what I mean? So yeah, I think that's another big thing. And I wonder if there's going to be like any type of gas auditing industry within like
I think that's starting to appear already. Like, I don't know about you, but when I was looking for freelance work, a lot of projects contacted me just for like my optimization skills. And also like Harrison on Twitter, he flexes or talks about it a lot, how like clients will pay him a lot to do gas audits for them and basically look at their code base and optimize it. So I do think there's a lot of potential there already.
Yeah.
And then as people realize like how big your savings can be, they will look for that more.
Yeah, Harrison is quite unique. Like he started the industry of gas auditing by himself through just a few memes and tweeting on Twitter, basically. And now he's basically running the industry. He's like a pioneer. He's just created a new kind of sector. It's like gas optimization audits instead of traditional security audits, which is very unique to blockchain, because gas is kind of how you pay for transactions. And so you want to obviously minimize that as much as possible, especially if you're using a protocol that has millions of transactions coming in. You want to reduce the fees for your users so they can do more transactions and not pay as much money. But there's also another thing that you've created, and it's a DEX. So how have you just switched from going from an auditor, doing all these hyper optimized contracts, to building circuit breakers and security standards, to now DEX?
So the DEX was also just a side project. I was kind of nerd sniped by Uniswap again.
Another snipe.
Of like, okay,
no, someone's on a kill.
Yeah, it's another snipe.
Call him the UAV.
I get sniped very easily. That's also a big drag on my productivity. Because whenever something just like I get a cool idea that like stimulates my brain and like, I have to do this because it'd be fun to implement.
Yeah.
And also I can show it off to people. I get like hypercharged and I have to like stop myself and delegate that. Like now the way I structure my week is basically, I don't always stick to it, but it has kind of worked till now, is that I say, okay, Friday to Sunday is my nerd snipe time. And then Monday through Thursday is like my DeReg primary project time.
Pointing your schedule.
But basically, yeah, the DEX was another nerd snipe because I saw, Uniswap released their V4 implementation. I forgot what the industry agreed the terminology would be, but they didn't open source it. They source available it.
It's got like a license,
so you can
exactly.
So you can read the source code. It'll be open source in like 4 years, but till then it belongs to Uniswap. So if you make any
like a business license or something,
exactly, they have a business license. So basically the terms, I read the business license, and basically what it says is that first 4 years is proprietary, and then after 4 years it automatically transitions into like a GPL copyleft license, which is like a traditional open source license. And so but basically till then, if you contribute to Uniswap, it'll belong to Uniswap. They'll be making money off it. So I recommend you don't, like, if you're really interested in Uniswap, like, sure, contribute to Uniswap. But just noting that if you contribute to Uniswap right now, it'll just be free work in the hands of a for-profit company, which there's nothing wrong in being like a for-profit startup. It's just like, don't get confused by their quote unquote open source marketing. But that aside, basically the DEX I wrote was inspired by Uniswap v4, because they introduced, or they didn't introduce, like other DEXs had this before, but basically they at least brought it to my attention, this like cool pattern of like flash accounting. So where you have like a bunch of transactions that can happen within a single contract, and then you just settle the result of that at the end, which is especially relevant for a DEX where you have like multiple pools that hold different tokens, that have different ticks, different liquidity, different fees, different hooks. And then you may be like routing your trade across like 10 different pools just to get like one token out. And it costs a lot of gas to transfer tokens from one pool to the next. Because every time you transfer a token, you have to call the token contract. It has to change the balances and then change the balances again. So instead, what Uniswap does is that it stores these changes internally. In the future, it will use EIP 1153. And then it basically, just the difference at the end is what you have to settle and like transfer tokens for. So
Yeah.
If you imagine like a swap going from like USDC to USDT to ETH to the Uni token to the compound token to whatever, at the end the only thing you have to transfer in is the beginnings, like the USDC, and at the end like your comp tokens or whatever, and then all the changes in between didn't have to like register.
Yeah, so it's like basically from its previous versions, it's not doing all these independent contract calls, which are, 2100 gas, or not 2100, it's even more. Is it 20? It must be a bit more, right?
No. Like the call, so a call costs 100 gas, and then you have like overhead from Solidity to like format the memory. And if it's the first time you're calling a certain contract, then it'll add another 2,500
Okay, yeah,
gas
that's what I was
to
thinking.
quote unquote warm the address.
Previous iterations were basically just calling each other from like one pool to another pool to another pool, depending on how long it was. And so you're sending tokens back and forth through all these pools. But basically V4 is just a centralized point of where all the contracts are. Not actually centralized. This is still on a decentralized network, Ethereum, but it's where everything is sort of hosted, right? And when you do one transaction, it doesn't route through external contracts, it just routes through itself. So it's using much less gas, isn't it? And
yeah, exactly. Yeah.
so your DEX compared to that, what is it like?
Yeah, so it does something similar, but the flash accounting, instead of using storage or in the future transient storage, it does it in memory. So because the way Uniswap v4 is intended to be used is you still have like a periphery router contract, but what it does is that it'll call into the v4 contract a bunch of times to do the individual swaps, but it's calling into the same contract, so that saves gas. So you're calling multiple times into one contract, but you're saving a lot of gas because you don't have different contracts, which saves a lot of overhead of just like external calls, and also you're saving on the cost of like warming separate accounts. And so my implementation takes it one step further. So it's all the swaps can be done within one single call.
Yep.
Directly within the DEX contract. You don't need a periphery contract, and all the flash accounting is not done in storage or transient storage. It's done in memory, which is cheaper than transient storage, but not that much cheaper, it turns out. But it is a bit cheaper. Okay. And so basically the way this works is that the DEX has its own like mini instruction set to like do different things. And then you can like pack these together to make a swap. So there's one instruction for swapping between two pool, swapping from one pool to the other, and then another. And then there's one instruction for like withdrawing or depositing tokens. And then you can also like set limits. And then that allows you to basically off-chain form like a script, or what I call a program, with these different instructions. You put them together and then send it to the DEX contract, and then it'll execute them across the different pools and then give you the result.
Sure. So it's basically just like hyper-optimized version of V4, really.
I mean, it's not that optimized because I haven't spent too much time on it, but the base, like, the flash accounting is done in memory, which is quite efficient, but I'm sure there's a lot, because I didn't write a lot of it in inline assembly, so there's probably a lot of gas I could save here and there.
Yeah, for sure.
That I did naively, but yeah, it is kind of optimized, yeah.
Right. So was I right with like the V4 and V2 comparison, and then your one's basically switching the storage to memory, really?
Yeah, exactly. So yeah.
Okay, perfect. I would like to touch on like just the productivity for a little bit, and then we might wrap it up. But during your kind of like journey, how did you kind of stay focused and make sure you were on the right track and not kind of getting distracted / procrastinating, as most of us do?
Yeah, that's actually something I've been struggling with recently, and so I might have trouble answering that. But in the past, it's been like bursts of productivity. I'm not sure if this is just because my attention span has been messed up by like modern social media, but the way I work is not really like concentrated for long time spans. It's basically it basically comes in bursts like throughout the day. So I'll get distracted for like a few minutes or like half an hour, and then I'll get back to work, and then I have like a focused burst of like 1.5 hours of work, and then I'll do something else like a chore at home, and then I'll have like another burst of like productivity. And that's like how it's been done, and just like making sure that I create the space and flexibility for me to be able to have these bursts is basically what has helped a lot. But I'm trying to also just get a more organized schedule in general. So I've been doing things like the Pomodoro technique to basically just like push myself to get these bursts more often.
Yeah.
As well as just like increasing the barrier to entry, so to say, to go to these distractions. To just like make it harder for myself. So when I really want to focus, I'll put my phone on do not disturb. I'll log out of Twitter so that if I want to go to Twitter, I actually have to like log in and enter like my credentials. So that's just that barrier alone often just stops me from opening it, because unless I'm actually taking a break in the day, I won't go through the effort of like unlocking my password manager or putting in the Twitter password or whatever, doing the two-factor.
Yeah.
So just creating a barrier to reach those distractions has also helped.
Word.
And yeah, just like setting time limits on the distractions, just like trying to minimize the distractions wherever possible, but also being kind of like reasonable with yourself, because you're human after all, and you do want to like let loose and just like doom scroll sometimes. So just like being intentional about that, because if you're being realistic, you're probably never going to eliminate that entirely. So just like allocating specific times of the day where you do that can be really helpful as well.
Like, yeah, just have like blocks of insane focus. It could even be like 4 hours or something. Then that's kind of, in 4 hours of insane laser focus, you can do a lot. It's highly underlooked of like how much you can do in such a short amount of time if you have, laser focus. If you really want to get rid of like procrastinating and all that stuff, get rid of the distractions in your environment, kind of limit yourself to what you're going to set a task to, set a schedule. Building the habits is really what matters. And then even on the days you don't feel like doing it emotionally and spiritually, or even physically, when you like burn out, you still have those habits of, giving your time sufficient rest, and then having those short periods of like laser focus, then resting again, taking care of your body and mind, so you just can be consistent. And that's kind of how you compound learning and progress. But I think on that note, I think it's been a terrific podcast. It was lovely having you on, Philip.
Yeah, thanks for having me on.
I'm glad we got to do this so quickly, at short notice as well. Just DM'd you. You're like, yo. But yeah, thank you so much, and I'm sure we'll jump on another one soon.